In today's rapidly evolving world, the life science industry is experiencing massive breakthroughs in healthcare technologies. Continual development and innovation in medical devices are crucial to ensuring quality of life across the world. Globally, medical device manufacturers are facing an increasingly competitive scenario that demands to reduce the cost and time to market, streamline their operations, and avoid liability lawsuits. With SOLIDWORKS Design and 3DEXPERIENCE Work simulation portfolio, medical device manufacturers can address these challenges easily. Here's an example of an asthma inhaler manufacturer trying to improve efficiency of drug delivery to the patient. The primary objective of the designer is to minimize pressure losses between inlet and out and obtain efficient drug delivery at the outlet of the inhaler. Designers can quickly assess flow performance of the inhaler design by launching the Fluid Dynamics Engineer role directly from SOLIDWORKS desktop. The Fluid Dynamics Engineer role offers guided interface for designers and simulation experts alike. Embedded in the cloud-based 3DEXPERIENCE platform, users can set up flow simulations directly on native SOLIDWORKS CAD geometry with minimal interaction. Access to custom and standard material databases are made easy with a quick search in Material Palette. In this case, the designer is able to capture two-way interactions between drug and air inside the inhaler by easily defining steady-state simulations with multi-species approach. The Fluid Dynamics Engineer role significantly reduces turnaround time for simulation model setup, with fully automatic fluid volume extraction and body-fitted meshing, including boundary layers, based on hex-dominant mesh technology. Users can execute flow simulations either locally with up to 16 embedded cores, or by leveraging cloud compute. The cloud-based collaborative environment on 3DEXPERIENCE platform enables companies to access high-performance computing resources to solve computationally expensive simulations, reduce software and hardware costs for IT infrastructure, and maintain data consistency, streamline processes, improve collaboration, avoid errors, and save time on version control. The status of simulation can be monitored in real time by getting updates on engineering KPIs such as pressure drop and mass fraction in case of the inhaler, and standard solution convergence parameters like mass balance and momentum residuals. A high-performance visualization engine enables extremely insightful information about flow performance to drive design improvement decisions. In the case of this inhaler, XY history plots and sensors allow the designer to gain confidence in convergence of KPI values, and 3D plots like streamlines provide non-intuitive insights into interaction between drug and air and how the mixture is delivered. Areas of recirculation and stagnation indicated by streamline plots provide guidance on areas for design improvement. Based on flow performance insights obtained by the Fluid Dynamics Engineer role, the inhaler design is improved in SOLIDWORKS desktop. Harnessing the power of CAD and PLM embedded simulation environment, the designer is able to automatically update the simulation model for revised SOLIDWORKS CAD in the 3DEXPERIENCE platform. Users can take advantage of powerful post-processing capabilities to compare simulation results side by side and assess the improvement in KPIs associated with flow performance. In this case, the velocity streamline plots, pressure drop, and mass fractions are clearly indicating that the revised design is more efficient. While steady-state simulations are performed to explore preliminary efficiency of various design alternatives, designers can easily scale up to transient simulations to obtain insights with higher fidelity for real-world performance. With SIMULIA's Fluid Dynamics Engineer role included in the 3DEXPERIENCE Works portfolio, designers can accelerate innovation while ensuring functional efficiency and improved quality for patient-friendly medical devices.